In the last video, I told you how you could multiply two matrices together. In this one, we'll do a few more examples a little bit faster as we continue um, talking about matrix multiplication. So let's look at, say, for example, B and D. And again, B and D would be allowed because the number of columns in B matches the number of rows in D. They're both 2. So that's the condition. And notice why that must work, because if we're going to do the inner product, which is what I was explaining in the last video, right? We're going to need to take the first row of B and multiply into the first column of D. That's just how it works. And that's kind of what I was saying is, well, why does it work this way? It's kind of hard to say, but that's just the way it must work. You don't take row into row or column into column or anything. It's always row in the first, column of the second. And notice that in order for this to match up, right, in order to take the inner product, I take 1 times 6 and 0 times 8. They both have to have the same, like, right, that the fact that that one had 2 columns and D had 2 rows makes it so that the numbers line up. If they weren't the proper dimension, you're not going to have the right number of numbers to multiply. And so for me, I don't memorize that I need to, have the right number of columns and rows. That's because that to me that's a little bit hard to remember. But what I just remember is, how do I actually do it? I take that row into that column, and the way I know if it's going to work or not is that if I have the right number of numbers. So this one will work because I do have the right number of numbers. And so when I'm going to get my product of B times D, the first inner product will be 1 times 6 plus 0 times 8. And that's, of course, going to be 6 plus 0, which is 6. The second element will be 1 times 0 going into 0 and 1. Sorry, not 1 times 0, but 1, 0 dot product with 0, 1, which would be 0 plus 0 is 0. And then I would have the first row into the third column, which would be 1 times negative 6, which is negative 6, and 0, which is 0. So negative 6 would be the last one. And notice that this one, since, like I said about 0 earlier, the 0 kind of negates each of those secondary elements because each one of those is multiplied by 0, but 1 keeps them all the same. So what I end up with is actually the exact same row that I had in D, because the first row was 1, 0, and when I multiplied through that inner product, it left me with just the same of the first row of D. And the reason why I bring this up is because of what multiplying by such a value like 1 comma 0 does. When I take the inner product with 1 and 0, it doesn't do anything. It keeps it the same, which is often referred to as an identity. And I'm going to talk a little bit about what is the identity matrix in a couple more videos. But that's kind of the importance of ones and zeros, is keeping things the same. If we wanted to, obviously, sometimes we don't want to. Like in the next ones, they will change because neither one is 0 or 1. But let's finish up the matrix multiplication of B times D. So I would take the second row into the first column, which would be negative 18 plus 8, which is negative 10. Then I would take the second row into the second column, which would be 0 and 1, which is 1. And then I take the second row into the third column. But notice my progression is I go row into column, column, column. Then I go row into column, column, column. And that's how I'm generating each of the numbers. I go row, column. Technically, you don't have to do them in the same order as I do. You could do row first, row second, row first, Sorry, I said that wrong, but this is just how I've programmed myself to do it so that I remember how to do it always, and it very methodically. So I kind of imagine taking this into each column, then I just rinse and repeat this into each column, then the third row into each column, and I just continue until I'm out of things to multiply. But anyways, the second row into the third column would give me positive 18 plus 9, which is 27. And then the third row into each column would be 2 times 6 is 12, plus 16 is 28. 2 times 0 is 0, 2 times 1 is 2. And then 2 times negative 6 is negative 12, and 2 times 9 is 18. Negative 12 plus 18 is 6. And assuming I didn't mess anything up, that should be my answer. Additionally, you can actually do matrix multiplication in your calculator if you want. So I'll go ahead and show you real quick how you do that as well. Because you can actually do most matrix mathematics with a general graphing calculator if you know how. So let's go ahead and do that. So all matrix math in the calculator is done via the matrix menu. So let me make this a little bit bigger. If you notice above the x to the -1 power in your calculator, there's a little button called matrix. And if we hit second matrix, we can access that menu, which basically pulls up the calculator's matrix menu. Now, basically, how your calculator works is it can store a lot of matrices in it at one time. So in the first window here, it's under names. It just lists all matrices that it stores by name. But currently, if you've never used this before, these are all probably blank matrices without any data. To actually edit them, you want to scroll over to Edit and then type them in. So say, for example, I wanted to program in this matrix B. What I could do is edit my matrix B, hit select it and hit enter. And this I could now craft this exact matrix, which my calculator would store within it. And since it has 3 rows and 2 columns, I would need to make sure to type in its dimension, 3 by 2. And then it will generate a matrix of the proper size. Typically, it will start with zeros, and then I would just need to type in those elements. So to type them in, notice it's asking me to enter in this matrix element 1, 1 of this matrix B, but that's just a 1, so I can type in 1 and hit enter, and it will then store in 1. 0 is already 0, so if you just keep hitting enter, you can continuously enter in the terms of this matrix. Then it has -3, hit enter, 1, hit enter, 2, enter, 2, enter. And basically I could store this matrix B in my calculator. Now, if I go back to my main entry screen by hitting quit, I could then enter that matrix and do math with it in my calculator by going back to the matrix menu. Notice that now matrix B is appearing as a 3 by 2 matrix. And if I hit enter right there, that will now put it into my normal math screen. And I could basically, your calculator is going to then do math with B. And then I could say, for example, take matrix B and multiply it by 3, right? So like we talked about scalar multiplication, I could take 3 times matrix B, and that would do exactly that math. Or I could take matrix B and add it to matrix C, or whatever. As long as it's going to satisfy the rules of matrix math, it should be good. But anyways, if I wanted to do this matrix math, B times D, I would then just also need to enter and store matrix D in my calculator, and then just tell it to do B times D. So again, to enter, I need to enter in D by going back to the matrix menu, scrolling over to edit. Let's just go ahead and use D. This one is 2 by 3. And this matrix is 6, 0, -6, 8, 1, 9. And then once I've hit enter on the last column, those should all be stored right in there. And then now, if I have them both stored, I could now tell my calculator to take matrix D times matrix B. So to do that, I access each matrix by going to the matrix menu and just using the names. So if I'm in the names set of the menu, basically, if I scroll down to number 2 and hit enter, that will insert B. Second matrix, go to 4 and hit enter, it will insert matrix D. But I can then take each matrix that I have saved and just insert them into my calculator to do math upon. So kind of the order is you want to store them first, then tell your calculator to do this math. I can then do matrix B times matrix D to check to make sure, did I actually do that all right? And really, I'm just showing you a way of checking my answers. So it looks like I did it right there, but it's helpful, when you're reviewing your matrix math, because there's a lot of steps, and the larger and larger the matrices, the larger those inner products become, and the more difficult it would be to actually do that math as well. So that's enough for this video. In the next video, we'll do a few more examples of matrix multiplication.